Good day, guys. Let's check another second order differential equation. Now we're getting to the ones where the right hand side is what is an exponential function. So, by the way, the beginning is the same to be the general solution, and that means we start with the complementary function yc. So, the starting of the complementary function doesn't change. You use the left side, you create a quadratic expression by making the second derivative r squared. Now you see there's no first derivative, which means our quadratic will only have two terms. So since there is no first derivative, it means that part is a 0. Then our y is forever 1. So that this becomes 4 times 1, which is 4, equal to 0. Since we don't use the right side for yc, we only use it for yp. So that is our simple quadratic. So it looks easy when we're solving it. If you look at this, you see that this is the difference between two squares, something like that. So you can solve without using the quadratic formula. And that shows that your R1 is a 2, and your R2 is a negative 2. So you see R1 and R2 are not the same. So if we now go to page 7 of the formula sheet for N6 students, our yc will be captured as a e to the power r1. So your r1 is 2 plus b e to the power r2. The r2 is a negative 2x. So our yc is that simple. So that's how we get our complementary function. So now we can go to our particular integral yp. So now that the right hand side is an exponential, your yp must also be an exponential. So how do we choose it? Very simple. You just make sure that your yp is equal to a constant multiplied by the exponential. You can still prefer to say 2c, but usually I just ignore the constant. My target is the exponential on the right hand side of the original differential equation. So it must be part of your yp. So that is the way it is. So that's how simple our yp is. But if this exponential is already appearing in yc, then my choice will not be that one. So we'll look at that type of a problem later. So the first thing I check is whether it's my exponential here appearing there. You see here we have e to the power 2x, e to the power negative 2x. It's different from that. Once it's not the same, then my yp is simple. I just take a constant multiplied by an exponential. So that's how it is. Then the procedure of differentiating does not change. You differentiate the first time, it stays the same. You differentiate the second time, it stays the same again. So that is it. Then that will help you get C. And how do you get C? You transfer this information into the original. So the second derivative will replace by the second derivative of yp. There is no first derivative, so we'll go straight to y, which will replace by yp. Then we'll equate to the right hand side to help us get C. So we're doing just that. So if we move on, the second derivative there will be replaced by c e to the power x minus 4. Our first derivative is c e to the power x is equal to the right hand side, which is 2 e to the power x. So if you look at what is written here, the like terms, it's like 1c minus 4c. It will give me negative 3c e to the power x is equal to 2 e to the power x. So you can see e appears on both sides, so e can take care of itself. Then I divide both sides by negative 3. It tells me that c is negative 2 over 3. And therefore, what becomes of my yp? My yp becomes negative 2 over 3 e to the power x. And what becomes of my general solution? My general solution, y which is equal to yc plus yp, simply becomes y to c. I got it down there. A e to the power 2x plus b e to the power negative 2x. Then your yp is negative 2 over 3 e to the power x. So as I keep telling you, if we're looking just for the general solution, then this is where we are going to end. So you can understand why I'm not solving general solutions, because by the time you have done particular solutions, indirectly you have done general. So now to go to particular solutions. condition, we need to look for the values of A and B, starting with our first condition, which says, y is 1 when x is 0. So if we substitute that into the general solution, we are replacing y by 1, and for x by 0, e to the power 0, we are very aware will give us 1. Another e to the power 0 is another 1. E to the power 0, it's 1 again, so I get 2 over 3 there. 2 over 3 becomes a friend to 1, because they are like terms, so if it crosses, it adds up to 1, and that should give us 5 over 3 is equal to A plus B. That is our equation number 1. Now, we can now switch to the next condition, which says dy by dx is equal to 1 when x is 0. We also, as before, we don't know what is dy dx. Each time we need dy dx, consult the general solution and differentiate it once. So if I differentiate my general solution once, I will get dy over dx is equal to 2a e to the power 2x. That is from here, when you differentiate this, you get negative 2b e to the power negative 2x. When you differentiate this, it stays the same, 2 over 3 e to the power x. So that's my dy dx. I can now replace dy dx by 1, while replacing f for x by 0. That will give me 2a plus e to the power 0 is 1 minus 2b. Then e to the power 0 is 1 minus 2 over 3. 2 over 3 is a like term to 1, as we've seen down there. It will give us 5 over 3 is equal to 2a minus 2b. To make my equation kind of friendly with the first equation, I can divide all through by 2. So I'll get 5 over 6 is equal to a minus b. So that's my equation 2. So I need to solve equation 1 and equation 2 simultaneously. I can use elimination method. So I'm going to take equation 1 minus equation 2. So equation 1 has 5 over 3 on the right. On the left, equation 2 has 5 over 6. So I'll be taking 5 over 3 minus 5 over 6. That leads me to 5 over 6. So on the left, I have 5 over 6. On the right, I get a minus a, which is a 0, b minus negative b, that gives me 2b. So then if I divide this side by 2, you will see we have b as 5 over 12. Now to get a, I can use any of the two equations. If I go for equation 2, then I use equation 2, which says 5 over 6 is equal to a minus b. That means 5 over 6 is equal to a minus 5 over 12. So to get a, I take 5 over 12 to the right. So I will get 5 over 6 plus 5 over 12. That gives me a as 5 over 4. So therefore, I can now write my particular solution by just copying the general solution. So that's what we are doing. Our general solution was y equal to a. Our a now is 5 over 4 e to the power 2x plus b, or b, what did we get? 5 over 12 e to the power negative 2x and minus 2 over 3x. So guys, this is what we call a particular solution for second order differential equations.